Hello guys, this lecture will be recorded only in English. So, to uh, to the students that wish to learn mathematics, they can also visit this lecture, which I will only upload in fully English. So basically, this is the start of AS Mathematics in English. Okay. So about this topic, some pre-requirements you need to know. If you would have done O levels, I don't know about any other syllabus than ONA levels because I also did ONA levels in Pakistan. So basically, in the start, I would like to write an equation just to clear some concept and misconceptions if some student or ward would have in his mind. So, and also one more thing, this lecture is only as a prerequisite or a pre-requirement lecture. So let's start. Now, in O levels, we learned to do middle term breaking, in which we took an equation, for example, 3x square minus 17x minus 6. We did middle term breaking in this equation. So let's start. What we did in middle term breaking is we took the first coefficient and the last coefficient and we multiplied it with its signs. Okay, please remember to account for signs. So 3 multiplied by minus 6 is equals to minus 18. All right, wait, minus 6 uh, minus 18. So minus 18, we need to get minus 18, and how we get it, we break the middle term. Just as the method suggests, we break the middle term into two parts. We're going to break it into, and we also account sign for it. We're going to break it into two parts, and if we multiply it, we can get this answer. All right, so if I break it in minus 18 x and 1 remains, so plus x, so we get minus 17. If we add this, we get minus 17, and if we multiply this, we get minus 18x. Okay, minus 18x square. So let's start. 3x square minus 18x plus x minus 6. Now if we would take these two common and these two common, we can say that 3x, taking these two commons, okay, x minus 6 and plus 1, because nothing can get in common, x minus 6. All right, so one term would be x is equals to x minus 6 is equals to 0. The other term would be 3x plus 1 is equals to 0. X would be equals to 6 on the first term, and x would be equals to minus 1 over 3 in the second term. Now this is what you used to do in O levels, but in A levels we can also use calculator. I would highly recommend a Casio calculator known as Classways. If you guys can use it, it would be better for you. So now let me find an equation, a good equation. Yeah, this equation. Now how we solve it in calculator to find the values of x, which would be, I would tell you, wait, we start our calculator, we go in the setup menu, we find the option menu which says equation and functions, we press equals to, we press 2, we select our polynomial degree is x square, so the polynomial degree of a square is 2. So the coefficient of x square is 1, the coefficient of x is minus 6, the coefficient of constant term, or just the constant term, is 9. We press equals to, we find two values which would be x is equals to 3, and the second would also be x is equals to 3. Now to save time, because in A levels exam we must save time, I would highly recommend to you guys to use this calculator and just find the two values of x. Why? Because we won't get marks for middle term breaking. If we show it, examiner can get happy, but we won't get marks. Now we want marks, that's why we use calculator to solve this. This was just a basic example of doing this. Alright, now let's advance to our A level section. Now I repeat, this is just an introductory class in which I would just tell you guys about the things that one learns in this chapter, which would be tested by the examiners in the Cambridge exams. Now, there's a standard quadratic equation which we all know, but I still would write it. That is ax square plus bx plus c. But sir, we didn't learn this equation. We actually saw everywhere in our A levels it was written just like this: 3x square plus 2x plus 3. So sir, what is this a, b and c? This a and b are the coefficient of x square and x. The c is the constant term which doesn't have a variable next to it. A variable is a alphabet. Just an easy example: a variable is a alphabet that we must find, that in mathematics we can find. Okay, now there are many methods to solve this quadratic equations. The three methods which, as far as I remember, are factorization, completing square methods, and quadratic formula. Now, one more last basic thing that I would like to tell you before I start my lecture. We all know how to solve this, right? We just take a simple basic under root and then we can say that x would be 6. But we can't solve this just because of one simple thing. And what is that one simple thing? That one simple thing is the sign next to it. Okay? Now, this would give you no solution in calculator, which is actually correct. You, the calculator is not malfunctioning, the answer is not -6. The answer actually, if we would know how to calculate it, we first should, this would be taught to you guys in next year in A2, when you guys would be taught about complex numbers, which is a very interesting topic. It would help you guys in university too. In, if you would choose the field of engineering, it would help you guys a lot, to be honest. Now to our main topic, and that is roots. In O levels, you used to find two values of x, sometimes one, sometimes two. And what that one value was, that was the value. Wait for a second, please. Wait, guys. That's the values of x. I'm back. Now, these values of x are also known as the roots of an equation. The answers we get, the values of x we get, are actually the roots. It's just a complex term, it's just a fancy term. No need to get scared of it, it's just a term. Now, what are roots? That's the main concept. Now, before I tell you what roots are, I will write three simple alphabets: D, D, and another D. And oh, it looks more like a triangle. I'm sorry. D, D, and D. One would be greater than 0, one would be equals to 0, and one would be less than 0. Now, sir, kindly explain. I will. Now, what is this D? Now, D is actually a short form of discriminant, not distance. Discri, discriminant. Now, what is discriminant? It is actually a formula that tells you the natures of a root, the natures of the curve, the nature of the parabola. The equation is d is equals to b square minus 4ac. Now, what is this b? What is this a? What is this c? Remember, I told you guys about a basic equation. Wow, I just learned this. The basic equation, the standard equation, which was ax square plus bx plus c. This equation told you guys this was a basic quadratic equation, but this a, b, and c are the values that must be used in this equation to give you the value of discriminant. Now, sir, what happens when you wrote three types of things? Then what happens if it's greater than zero? What would happen if it's less than zero? What would happen if it's less equals to zero? Now, three things happens. To let you guys understand it more better, I would draw two graphs first. And another thing, a better thing to learn, which I forgot to tell you guys about, is also this A. This A. What is this A? This A is basically the coefficient of x square. Now, this thing denotes two things. If this value A would be less than 0, would be greater than 0, or if it's less than 0. We would normally encounter many terms in our A levels we had encountered in which it was sometimes in negative, it was sometimes in positive. But in A levels, we would learn what happens if it's in negative or it's positive. The main concept, the main thing that changes if these terms, if these values are in negative or positive, let me write it here, positive values, because it is greater than 0, and here negative values. If it would be greater than 0, meaning if the coefficient of x square would be positive, the graph would actually turn out to be a smiley face parabolic graph, parabolic curve. This is a type of curve which, again, we would not get into detail because it is not in our syllabus to learn about the types of curves. We would just need to say that this is a parabola because it is a parabola. Now, if it would be greater than 0, then the shape of the parabola would be a smiley faced. Smiley faced. Smiley faced or U-shaped, or like a union sign, if you would remember the sign of union from sets in O levels. Smiley faced, Smiley faced, U-shaped. If it would be less than 0, or if the coefficient of x square would be negative, then it would be a sad faced graph, sad faced curve, sad faced curve, or U-shaped. Now, what would be its shape? Its shape would be like this. Okay, sir, thank you. You told us, but can you get back into the thing that you just missed, which was this? I am. I didn't forgot. I didn't forget it. I just am getting back onto it. Now, first of all, greater than 0. What happens when the discriminant value or d is greater than 0? Let's just take equation in account. For example, we have a equation, a quadratic equation, which has two roots. Wait, and the equation is 3x square plus 9x plus 10. It's just a basic example. Let's just shift these values here and here. Okay, the discriminant formula was d is equals to b square, which means 3, the square of 3, minus 4, the coefficient of x square, which is a, and constant term, which is 10. 9 times 10 is 90, and 90 times 4 is 36, and 360. I'll just confirm it because anyone in the world can be wrong. What have I done? Okay, first let's just change it. What happens if it's less than 0? I apologize because I just made this equation minus 360. It's no, I just made this in my mind. So if it would be less than 0, then 9 minus 360 is 351. 351 is the discriminant value. Now if it would be less than 0, it means that the graph, the roots of the equation would be complex roots, because the discriminant value is less than 0. The second example which I would like to give you guys would be of what happens when d is equals to 0. It's a funny thing. When discriminant would be 0, that first I would write the formula of discriminant, b square minus 4ac. Then I would write an equation which I just made up in my mind, which would be 4x square plus 4x square plus wait, yeah, it's actually correct what I had in my mind. So this is so what is b? B is the coefficient of x. All right, 4, the square of 4, minus 4 times a, the coefficient of x square, which is a, and 1. 16 minus 16 is equals to the value of discriminant. Then we would see that the value of discriminant would be actually be 0. Now sir, what happens when the value of discriminant would be 0? We would say, and we would write also in our Cambridge paper, okay, wait, this I'm not, it's this lecture is basically just an introductory lecture. It would just be here to give you guys the basic know-how of what we would learn and what we would need to solve in this chapter. All right, that's not a D. This is a D. And if it would be equals to 0, we would say that the equation, that the roots are real and equal. Now, second thing done. The third example and the final example before I move on to the graphs of these all discriminants would be what happens sir when d would be greater than 0. Let's just write the formula first. Solve it like I do too, okay? First we write the formula b square minus 4ac. Then let me just make an example in my mind. Wait for a second please. This is actually C, not a shiny A. Sorry, fancy A. Like I told you guys, English is not my first language. Let's take an equation which would be 3x square plus 10x minus 1. So let's put down the values. B is the coefficient of x, which is 10. The whole square of 10 would be 100 minus 4, which is in the formula, and a, which is the coefficient of x square, and c, which is minus 1. Minus by minus multiplies by minus and it gets plus. Through 4 times 3 is 12, and 10, the square of 10 is 100. Okay, d discriminant would be 112. Okay, now it is a positive value, yes. So we would say that if the value of discriminant would be greater than 0, we can say that the roots are real and distinct. Alright, let's move on to the graphs of the same thing. Yes, sketching, if any would have be getting this, if anyone would be getting this question in mind, it's actually 6 in the morning right now, so I'm actually tired. If anyone would be getting this question in mind that sir, is there sketching or types, or if in A levels there are questions of sketching given, yes, there are questions of sketching given in A levels, but not many, but there is still. So I would like to tell you guys to just learn this thing, sketching of a quadratic graph. I will just draw two graphs here, but one would have a coefficient of x square which would be greater than 0, and the second one would have the coefficient of x square which would be less than 0. Now what happens if it's greater than 0 and less than 0? Like I told you above in the two example of graph, it would be a smiley face and a sad face. The smiley face would be the one in which the coefficient of x square is, which actually is a, which is actually positive, would turn out to be a smiley face, and the other one would be vice versa. Okay, let's draw a graph. Now this is the example I'm giving you guys for if the discriminant is greater than 0. Discriminant is greater than 0. Okay, how would the graph look like? Now when the discriminant value is greater than 0, it means that the parabola curve or the curve would intersect it two at two distinct points. I repeat, when the value of discriminant would be greater than 0, it means that the graph or the parabola would intersect either x-axis or y-axis and at two distinct points. That is why the name it is given is also known as real and distinct roots, because it would intersect at two distinct points. Okay, I hope you guys understand. Now let's draw a graph. Graph would actually look out something like this, turn out to be something like this. Now x and x, the peak point or the minimum point of a parabolic curve is known as its vertex, and like I showed you, it is intersecting at two distinct points. When it happens only and only when the value of the discriminant is greater than 0 and the coefficient of a would also be greater than 0. Now I'll just write this. I'll write this later. First, the second example. What happens, sir, if the value of the discriminant is greater than 0 but the coefficient of x square is less than 0? Then what happens is we get the opposite graph. We get a sad face graph. I'm sorry, I don't draw well, to be honest. The last time I drew something was back in uh, I don't know, grade 1, grade 2. So when do we get this graph? We get this graph when the discriminant is greater than 0, which means the roots would be real and distinct, and the coefficient of the coefficient of x square would be negative. As an example, I'll just write this here. Okay, x square is positive, equals to positive. In here, x square would be negative, less than 0, negative. X square would be positive and x square would be negative, positive, negative. Now this point, like I told you before, is vertex. The peak and the minimum point are known as a vertex. Now this graph would be for the roots of this graph, as the discriminant value would be greater than 0, would be known as real and distinct. The things that I write with red and golden color are really important. Red, real and distinct. I apologize for any spelling mistakes. Now the second example I would like to give you guys. What happens, sir, if the discriminant is equals to 0? If it is equals to 0, then two things happens under two separate conditions. If the coefficient of x square or a would be greater than 0, and the coefficient of x square would be less than 0. If it's greater than 0, then the first thing that happens is we get a curve, a smiley faced, just as I told you beforehand, smiley faced. Like the emoji. In this we get a sad faced. In smiley faced we get a curve, but it only touches at a single point, which would be this, which would also be its vertex. And if it's a sad face curve, we get the reflection on x-axis and we get this type of curve. My drawing, why? Vertex. This happens when the coefficient of x square, otherwise a, is less than 0, otherwise the coefficient of x square is negative. Now the third and the last example. What happens, sir, if we get the value of discriminant to be less than 0? If we solve the equation and we find that the value of discriminant is less than 0, then, oh, I forgot to write it here. It this When it's equals to 0, the roots turn out to be real and equal. Okay, we need to write this, what I'm writing in bracket in your paper, if the examiner asks. Only and if and only if the examiner asks. Don't be clever while doing paper. You do something extra which the examiner does not ask, you won't get any marks for the extra work you do. The examiner only needs what he asks. Okay, that's that. Now if discriminant would be less than 0, two things happen again. First thing that happens, first I would draw two graphs, not this graph. First graph, second graph. Now in the first graph, the coefficient of x square is greater than 0. The second graph, the coefficient of x square is less than 0. If it's greater than 0, then we because it's greater than 0, we get a smiley faced curve. But it won't touch any line or point. Remember that. Alright, this would be its vertex. So as you can see, it doesn't cut any point in the curve. If it's less than 0, if the coefficient of x square is less than 0 and the discriminant value is also less than 0, then we get a sad faced curve, which would be very sad because it didn't meet anyone vertex. Alright, now I'll just write it all below it for you guys to copy. This would be complex roots, okay? If the value of discriminant is less than 0, then we would say that such and such roots are complex roots, okay? Now, from here, I'll write something. Wait, where it's working. Wait for a second, please. After this, I'll just end the lecture. Wait for a second. Now, thanks for waiting. Like I said, if the discriminant, the value of discriminant d is greater than 0, we get real and distinct roots, while the shape oh, wait while the shape of the parabola depends solely upon depends upon the coefficient of x square, which is actually a. Okay, the same thing here. If the value of discriminant would be equal to 0, I'll just write it in English, would be equal to 0, then then we would say that the roots are real and equal, while the shape depends upon the coefficient of x square, the coefficient of x square, alright, which is a. Please write it, the things I write in golden and red, please write this, okay? It's very important. Now, if discriminant would be, my fingers they hurt, less than 0, we would say that the roots are complex, whereas the shape of the parabola depends upon the coefficient of x square, which is a. Okay, now listen, this was only an introductory lecture. I am actually signing off. This is actually an introductory lecture in which I just gave you the basic concept of what one learns in this uh, chapter. Okay, in the next lecture I would start from the start and I would try to solve past paper questions with me, and I hope you guys would also solve past paper questions which I would write here. If you like this lecture, please like and subscribe, and please share with others. And also, if I did a mistake anywhere and if you would actually catch my mistake, kindly do tell me in the comment section so that others may be of help and I would correct it in the next lecture. Okay, thank you very much to learn this, and I'm actually sleepy right now, so I hope you guys would learn this, and I'm signing off. Okay, goodbye. I don't know what I'm saying right now.